Hi, everybody. Welcome to another virtual tour of our solar system. My name is Josh. I'm from the Morrison Planetarium. It is our privilege to be live casting to your house to get to do an astronomy program, the kind we like to do at the Academy. Since we're all under shelter in place, though, this is something very fun for us to get to do with you as we tour the solar system together. So, we have been starting off, hopefully, a place that none of you are from. This is Jupiter. It's pretty far away from home. If you want to tell us where you are from somewhere on planet Earth, feel free to drop that in the comments. We always like to know where people are tuning in from. Another great thing to let us know would be is if there's something in the solar system you think would be super cool to check out, something you'd like to visit today, drop that in the comments as well, and we would be happy to take suggestions on where our next destination is. So right now we are heading away from Jupiter. That's a pretty tough place to start a tour, and heading to this blue glimmery sliver of a planet. Anybody know where that is? This is planet Earth. How can we tell? Well, something really cool. You might notice there's kind of a glint, a shimmer coming off the surface, and that is water. Liquid water on the surface of planet Earth. You might also notice some of this glowy stuff on the backside. Very few planets have something like that. I would guess this is Africa. How do we know? Well, there's one really cool, really distinctive feature you can spot on Africa. Check out this Nile River right here. It glows brightly. The entire delta has that nice delta shape like the Greek letter, and you can see it glowing from high, high above. Now, as we fly around planet Earth, you'll notice the nighttime side of our planet. It's a little tougher to see. This planetarium software we're using is called OpenSpace. You can find out more on the OpenSpaceProject.com. You can download it for yourself. It's a different kind of planetarium software, not just a kind of closed box for us in the planetarium field to be playing around with. It's something you can check out at home. Now, when we use this software, it's actually showing us the correct time and date. This is what our solar system would be looking like right now. I've not done too much monkeying around, even though you could, to change what time and space would look like. So right now, we are on the daytime side of planet Earth, looking at our very own San Francisco Bay Area. Now, one thing you might notice, there's not a single cloud in the sky. This is a satellite composite set of images taken over many different time periods, all put together to give us a great view. You can pick out features like the fair lawns hanging out there. You can see the bay itself and some of the really cool patterns and currents that move throughout it. But if I zoom back, we can bring in something that's a pretty constant feature of the Bay Area, clouds. Now, these clouds actually do match what we should have been seeing not too long ago. In fact, just yesterday, right around noon. So we got folks tuning in from all over the place. Philadelphia, I see, New Jersey, all the way across the coast. So maybe we won't spend too much time in California and the Bay Area. Maybe we can take a tour across the US. We're saying goodbye to the Sierra Nevada over here, coming over the Rockies and to the plains, right around the Great Lakes area. Oop, a little far north for the Great Lakes. There we go. And over here, you might notice things are a little darker, a little harder to see. Like I said, this software tracks what time it is. And for anyone who thinks Earth is not a sphere, here's a really good thing to ask them. Why do we have time zones? It's already nighttime over on the East Coast. It's daytime here in San Francisco. Turns out, as Earth keeps spinning, different parts of us enter into nighttime, different parts enter into daytime. It's part of living on a sphere. Now we can see where morning is occurring, where the sun has just risen over here in Australia, and we can actually see clouds over Australia too. Spending time looking around planet Earth is always a fun thing to check out, and there are always more cool things to see. But for right now, I think we should head off to a spot in the solar system with even more prodigious clouds than us. We're going to head back to where we started. We're heading to Jupiter. Now, when we see clouds on Earth, they are the parts of our air, parts of our atmosphere that are hard to see through. When we look at Jupiter, you could say it's all clouds, or the air is clouds because we can't see through them. But we can see some similar effects. On Earth, we have weather bands that move stuff from east to west, west to east across our planet. You see something kind of similar on Jupiter. There's a lot of wind moving in that direction. Similar forces are happening here. Now, in Jupiter, we have what are called zones and bands. They alternate with dark and light regions across the surface. If I recall correctly, bands are dark, zones are white or lighter. But those alternating bands are places where the temperature, the upwelling and sinking down of convection, kind of like a pot of boiling water, is interacting. Now, from these cloudy features, we can see some pretty cool stuff, like this gigantic storm up here. We call it the Great Red Spot, or the Eye of Jupiter. Now, these are some Hubble photographs that were stitched together by our engineers, allowing us a really cool view of the entire surface of Jupiter, even though normally it might look a little bit more like this, because like Earth, Jupiter has nighttime and daytime. But we want to see that cool feature, that great red eye, so we are altering our planetarium software's imagining of our solar system to give us that extra detail. Now, when you look at that great red spot, this is a nice thing because it gives us a sense of scale. If you were to go from one side of the great red spot to just past the center eye, that's about the size of planet Earth. Now, that means Jupiter is absolutely gigantic in comparison. The great red spot itself is at its smallest depiction, the one you're seeing here, about an Earth and a half wide. Older photographs show us that the great red spot used to be a little bigger, maybe about 3 Earths wide in some of the bigger shots. But that seems to be shrinking over time. We're not 100% sure why that's happening, but there's ongoing studies, and Juno, one of the spacecraft that's in orbit around Jupiter, might help crack the secret. Now, you can see one of my other favorite features on Jupiter right up here. This popped up in some of those Hubble photos. They called it Jupy McJove face, or Jovie McJupe face, or any permutation of them. The internet loves silly names, but it's a really interesting and distinguished feature on the surface of Jupiter. But just like Earth clouds, people love imagining different shapes, different things you can see on the surface. Oh, we got a request for Pluto. So I think this would be a great time to shoot into the outer part of our solar system, traveling much farther from the sun. When we're talking about Jupiter, pardon me, my dog wants to be on the cast too. When we're talking about Jupiter, we are talking about a planet that is pretty far from the sun. I would say it's probably about 40 light minutes away from the sun, meaning that if something changes on the sun, it takes about 40 minutes for it to get to Jupiter. It might be closer to 28 now that I think about it. But when we're talking about Jupiter, this is a pretty distant planet. Pluto is about 4 light hours from the sun. So if something changed on the sun, we here on Earth would know about it about 8.5 minutes later. People, if they were hanging out around Jupiter, would know about it about, I'm saying maybe 30 minutes. I'll split the difference. And out here on Pluto, they wouldn't know about it for about 4 hours because it would take the light that long to reach them. Now, we don't think there's anybody hanging out on Pluto. If they were hanging out on Pluto, they'd be exceptionally cool. Not in the charismatic and suave sense of cool. They'd be really cold. The farther you get from the sun, the chillier things are. So when you look around Pluto, this bumpy, cratery surface with all these cracks and almost river-like channels might make you think of rocks here on planet Earth. But I'd say a closer match might be glaciers or ice fields, because the rock of Pluto is actually water. It's frozen solid, much like our rock is frozen solid magma or lava. This is frozen solid water or ice. Now, when you're looking at these icy features, they behave like rock in several ways. One thing that changes a bit, though, is how it is affected by sunlight. When you shine sunlight on rock, it gets a little warmer, but it doesn't melt. Ice would, especially under direct hot sunlight, even this far from the sun. So when sunlight shines down onto this surface, it starts to melt. I shouldn't say melt, because it doesn't actually turn to a liquid. When you take ice and you get it energetic enough that it becomes a gas immediately, we call that process sublimation, turning from a solid to a gas. And that's what's sculpting some of the mountains we see on Pluto. You can see this bizarro icy surface in a couple other ways. This is one of my favorite features. I feel like we visit this every week, so if you get sick of it, just tell me. But man, I love this stuff. This is a nitrogen ocean, kind of like a slush pool on the surface of Pluto. Now, this slush pool kind of looks like a pot of boiling water. We think the same kind of thing is happening, convection. Hotter stuff is rising up, cooler stuff is sinking down. Convection is a fundamental physical process. It changes our weather here on Earth, where hot air rises, cool air sinks. It changes the clouds on Jupiter, where they are constantly stirring around. You can see its action here on the surface of Pluto with the convection currents and that slushy ocean of nitrogen. That's air here on Earth. But where else might we spot convection in our solar system? Well, the thing our solar system is named for is our sun. Solar system. Sol is Latin for sun. So let's go check out the sun's surface. Now, this again is going to be about a 4 light-hour trip. If we traveled at the speed of light, you'd think it would go really fast, but it would still be 4 hours. That is a long time. Are there any way to find more planets like Pluto in our solar system? Ooh, so what happened to Pluto was we actually changed its categorization. In our solar system, I would say handily, there used to be two classes of objects. According to most astronomers who weren't being too careful, you had the sun and things that go around the sun. The biggest of those things were called planets. The smallest might be called motes of dust, or just little bits. Like basically dust would be a good term for it. Now, our sun is doing something kind of special. We call it fusion. And if you weren't doing fusion, you weren't a star. The big things were called planets. Now, that works pretty well, but there are some nuances that system was missing. So moving away from our sun, are we going to discover more things? Pluto, where planets stopped being part of the planets of our solar system because it started being part of another group. Now, let's see. I'm going to tell you a story we told a long time ago about an object that traveled around our sun. And that object, as it traveled around our sun, was once called a planet. But then astronomers with new and more powerful telescopes discovered that this thing, as it traveled around the sun, wasn't alone. There were other things that traveled around the sun with it. First, they discovered one, and then another, and then another, and another, and another. And as things kept progressing, eventually they had discovered dozens, hundreds of these things, and they decided that what they used to call a planet wasn't. Now, you might be thinking, I'm talking about Pluto, because I've been sneaky and pretending I'm talking about Pluto too, but in actuality, I'm talking about something that exists between Mars and Jupiter. This is Ceres. Now, Ceres used to be a planet, just like Pluto used to be a planet. But when astronomers discovered the rest of the asteroid belt, we decided Ceres wasn't a planet. It was more in common with the asteroids, so we changed what we called it. But Ceres does have a little bit in common with Pluto. It's a bumpy, cratery surface. There's probably the presence of water on it, although some people think it could be liquid water under the surface of Ceres, which would be pretty amazing. But when we're talking about Ceres and Pluto, they are both something else now. They're not planets, they're called dwarf planets. In our solar system, we've got, I think, under a dozen dwarf planets currently, but I think that list is going to grow a lot. When we're talking about these dwarf planets, it actually opens up an interesting kind of can of worms. How many small objects do we have in our solar system? I don't think many scientists out there would be willing to state an answer confidently, because we are always going to find more small things. So between Mars and Jupiter, we have thousands of dwarf planety objects called asteroids, and they fall into many different groups. If you download the brand new version of OpenSpace, you can actually check out these asteroids for yourself. They're a brand new feature. I don't have the new one loaded on my computer yet. But there is one super cool object I would love to visit. We don't get many requests for this. It's kind of the best kept secrets of the solar system. But we are heading out to an almost perfect match of Pluto. And which planet is it orbiting? Neptune. Oop, way out here, you can see a gray ball. This is Triton. Now, Triton might load up in just a sec, but if it doesn't, I'll take you someplace more interesting. But Triton actually has a lot in common with Pluto. Turns out Triton and Pluto are a very similar class of objects. They have a lot in common with each other. Triton even has a little thin atmosphere, we think, that would make it an almost perfect match for Pluto. So we think once upon a time, there might have been about 2,000 Pluto-sized objects in our solar system, but then something happened. As the rest of our solar system began to form up and finalize, as the big planets started moving around, they interacted gravitationally with these smaller objects and began to fling them out of the solar system. Now, some of them might have gotten flung into Jupiter. Others might have been flung into Jupiter, or into the sun. And some of them might have been flung into Jupiter. But over time, it was attrition. More and more of them began to become lost. Some of them got snatched by planets, like that's the story for Triton, most probably. Some of them probably left our solar system entirely and just sailed away. But as we start looking at the history of our solar system, we can see The solar system we know today is just a snapshot. It's not something that's unchanging and perfect and always going to be like this. It's always changing. So right now we talk about one of the coolest features of our solar system is the rings of Saturn. Now Saturn's rings are absolutely beautiful, but please don't be heartbroken when I tell you they're not going to be there forever. The rings of Saturn seem to be disappearing over time. Now, we think they may have formed from a moon that got just a little too close to Saturn and got stretched gravitationally, pulled apart. Parts of it bumped into other parts, and it slowly ground itself finer and finer to become the rings we see today. That's one possible origin for them. It's one that I think is pretty well supported scientifically these days, though. Now, those rings formed a while ago and are disappearing. Not quickly, but particles are probably settling down onto the surface of Saturn and disappearing from those rings. And because of that, we are seeing those rings get more and more rarefied. Maybe one day they will disappear entirely, and we'll have to wait for Saturn to grind up a new moon. Ooh, make. Well, for our outer dwarf planets, I can only show you a couple things, like our dwarf planet trails. Now, I would love to fly you up to the surface of Makemake and show you all the amazing features that exist there, but we got a big problem. How many missions have flown to Makemake? Way out here, that blue line? None. Turns out there are no missions that have gone to the outer parts of that chunk of the solar system. We don't have any close-up photos. Now, powerful telescopes like Hubble can take shots. Actually, that might have been Pluto. Yeah, that's still Pluto's orbit. Makemake's trail is not showing up for some reason. But when we talk about these distant objects, we know of them. We've got a few high-power telescopic images of them, but not quite to the quality we have of Pluto because a mission has never flown past them. That's what would be required to get that kind of ultra-high-res imagery. With satellites that use solar panels for energy, how do you clean debris and dust from the solar panels to make sure they don't get damaged by space trash? Cool question. Let's head to Earth, where a lot of our spacecraft are, to see if we can look at that problem. So right now, when we look at Earth, you can't see any spacecraft, right? Is that because our software and my computer's limitations, we can't see all those tiny points flying around us, even though they'd actually be there, or we're not showing you them because they're too hard for our computers to handle? They wouldn't be visible anyway. It turns out, even though we do have a lot of stuff orbiting Earth, it's all very fine points. They're so small and so far apart that from a view like this, you'd be hard-pressed to see any that weren't directly bouncing sunlight towards you. Now, how do we clear off the dust and debris that fall onto their solar panels up here? There just isn't much. Because there's so much space and so little stuff in space, when you're above the atmosphere of planet Earth, you don't have too many considerations of dust or wind because those are problems inside the atmosphere of Earth. And if you want to see how thick Earth's atmosphere is, we can actually get a great view from the nighttime side. See that glowy bit extending around the edge? That is a really good visual of how thick Earth's atmosphere is. It's only about 6 miles thick, depending on what you consider the outer edge of the atmosphere. So it's practically nothing. By the time we're talking about a low Earth orbit, which might look something like this for the ISS or for Hubble, a couple 100 miles above the surface, that's so far away from a lot of the dust and atmosphere that it's really not that much of a concern. Now, if you land on a place like Mars, which is famous for wind and dust, it suddenly becomes a big concern again. But in space, there's no wind. There's nothing really to bump into. It is a really easy environment to keep things clean in. The concerns would be stuff like radiation from the sun, as well as some micrometeorites. Micrometeorites are just pretty much anything, a little tiny piece of plastic, even a part of a glove traveling at many thousands of miles per hour slamming into you would make for a pretty bad day. Now, are there any missions to the outer solar system? Well, once upon a time, there was, I believe, a group of missions called the New Explorers. They were going to be sent out from planet Earth to go visit the outer parts of our solar system and teach us awesome new stuff. If I recall correctly, there were more than 10, I think, maybe 12. They were going to be sent out from planet Earth, but how many of them actually got sent? One. A single new explorer. That was New Horizons. Now, we're very glad New Horizons happened, but the outer parts of our solar system, as amazing and wonderful and question-filled as they are, we just don't have anything planned currently to go visit. Now, we are sending the Europa Clipper, which is going to visit Jupiter, past the asteroid belt, so technically the outer solar system. But I think of outer solar system as the realm of our ice giants, Uranus and Neptune, and beyond. Maybe we need a middle part of our solar system, but no one agrees with me on that classification. Okay, zooming back a little more, you can see just how big our solar system is. Our sun way down there in the middle, and the orbit of Pluto way out here, about 4.5 light hours across, not light years. That would be a lot bigger. That is our solar system. But it's still a pretty cool solar system. If there's anything else in there you would like to check out, please let us know in the comments. Otherwise, I think I've got another really cool thing to see, someplace that sounds exciting to explore. Now, I have a lot of favorite moons in our solar system. One of my coworkers keeps pointing out to me that every time I do a tour of the solar system, I have a different favorite moon. So I'm going to add the caveat of saying that this is my current favorite moon because it's the one I'm thinking about right now. We are going to one of Mars's 2 moons. This is a cool moon called Phobos. Now, I used to call it Phobos because that's what it looks like, but people who speak better Greek than I do have told me Phobos is a little bit closer to what we should be saying. It means fear, and fear and panic were the names of the 2 Martian moons. The other one is Deimos. But when you look at Phobos and Deimos, they immediately don't look like our moon. They don't even look like Pluto's moon. These look like space potatoes. Now, space potato is a great term astronomers coined for little tiny rocky objects, things kind of like an asteroid. In fact, these might have been asteroids. Just like Triton managed to get snared by Neptune, Deimos and Phobos might have been snared by Mars. Mars isn't as big a planet as Neptune. It's a little smaller, so it snatched smaller objects. Now, when you look at Phobos up close, you can see it's not round, and that tells us it's small. Any object in space that's round must be pretty big, or else made of very soft stuff. If you're made of hard stuff like rock and you're not round, it's because you don't have enough mass, enough stuff in one place to squish the whole surface together, kind of kneading itself into a nice round shape. So one really cool thing, a factoid I learned about Phobos, is if you imagine going to the Mars side of Phobos, the side that faces towards the surface of Mars, and you threw a baseball, you could probably actually hit Mars. Now, that sounds absolutely far-fetched to throw a baseball that far, but the gravity to escape Phobos is practically nothing. And once you escape that gravity, eventually the gravitational pull of Mars would get stronger and stronger and pull the ball into the surface. Now, that's kind of a cool thing to think about, but throwing a baseball, the baseball is still moving pretty fast. Well, I got something even cooler. If we go out to the orbit of Deimos, just a little farther from Mars, you can see it out here. That second orbit popping up, this is for an even tinier object. From Deimos, if you got a ramp and you could somehow magically still bike on the surface, you would actually be able to get enough speed going, you would launch off the surface, and you'd have to worry about crashing into Mars. Now, that means you could act out that scene from E.T. pretty much legitimately. One thing from that movie that could be even loosely grounded in science. Okay. Any other requests? We are happy to field them. But for right now, we're going to take a big slide backwards and show you something that I think is really cool. We had some questions about this not too long ago. I'm going to show you the trails of our planets one more time. See them there? When you look at the system of planets we exist within, I'm going to lock us on the sun for convenience's sake. You can see most of the planets are very close to one plane. You imagine if you took our solar system and put it on a plate, most of the planets would rest pretty comfortably on that plate. they're flat. Pluto, of course, has to be the problem child, goes a little bit above and below the plane of our solar system. You can see that thin blue line on the outer edge. You can also notice that Ceres is pretty far off the plate too. Not that as bad as Pluto, but a little bit. This kind of incline tells us a little bit about how the object formed, whether it was a more chaotic and active part of the solar system. But a lot of questions people have is whether or not these plane line up with our Milky Way. You can see that in the background here. The Milky Way is a beautiful sky feature that's actually the galaxy we live inside. Now, you could sort of imagine as a bad comparison, our solar system might be like a cell. The Milky Way would be the body. We're one small part of a much bigger thing. You could say the Milky Way would be North America, and the solar system is our house. We're one small part of a much larger system. But I think that comparison for houses especially is off by at least a couple orders of magnitude. Now, when we're looking at the Milky Way, all the light in it is coming from other stars, places not too dissimilar from our sun. Now, our solar system does not line up with our galaxy. In fact, there doesn't seem to be a strong orientation between any of the solar systems we have spotted and the plane of our galaxy. So even though they're kind of similar shapes, they're both sort of flat, they don't line up perfectly, and the rotation of our galaxy does not define the rotation of our solar system. It's pretty different. We are heading back into our innermost part of our solar system, the area right around our sun. Here in South San Francisco, where I live, we're getting pretty familiar with the sun. It's a hot day. We're receiving sunlight directly because we just passed our solstice. And if you want to find out a little bit more about the solstice and some of the cool stuff you can see in our daytime and nighttime sky, you're going to want to tune in tomorrow to Bing's broadcast. He's actually doing our producing role today. You can find out about all the cool stuff visible in our night sky. If you want to find out more stuff about astronomy as it happens here on planet Earth, make sure that you tune in for our Friday broadcast, where we're going to be featuring an astronomer from Chile. And Barbara is going to be telling us a little bit about some of the really cool astronomy that they're doing down there. We're going to be hearing from Ryan Wyatt, our own senior director. And come Tuesday, I'll be tuning in again. Mary is taking a well-deserved vacation, so I get to do the Fun Kids program on Tuesday mornings at 9:30. Make sure you tune in for some moon exploration. So on behalf of myself and the Morrison team, we are overjoyed that all of you tuned in today from all of these places all over North America to see our broadcast. If you want to do some fancy flying yourself, make sure you download OpenSpace and check it out. On behalf of myself and Morrison Planetarium, thank you all for joining us here for our virtual tour of outer space, and have a wonderful rest of your day. Thanks again.